Hello and welcome to Amazon Web Services webcast, introducing Amazon ECS CLI. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A pod. Please submit your questions for our presenter and Q&A moderators at any time, and we will address them in today's presentation as well as in the live Q&A session in the end. At the conclusion of today's presentation, there will be 3 poll questions proceeding like Q&A. Today's webcast is being recorded, and we will send you a follow-up email with the URL to the recording, as well as a link to the presentation deck. And again, welcome to today's webinar, Introducing Amazon ECS CLI. Our presenter is Chris Buckley. Chris is the product manager for Amazon EC2 Container Service. Before Amazon, he worked as a product manager, a developer, and various other roles in a handful of software companies, ranging from one of the world's largest to some of the world's smallest. Today with us, we also have Andrew Thomas, Senior Technical Product Manager. Andrew will engage with you and answer your questions throughout the presentation while Chris presents. Chris, welcome. I now pass the floor to you.
Thank you, Bowen, and thank you everyone for joining us today. Really appreciate you taking the time to come and hear a little bit about Amazon ECS and the ECS CLI. Please feel free to use the Q&A section of this session while I'm speaking if you want, and we'll take questions at the end. So just quickly, an agenda for today's webinar. We're first going to just give you a brief overview of containers. I'm sure most everyone on the phone is pretty familiar with them, so keep it super brief. Talk a little bit about the EC2 container service and how you can use ECS for running your containers, and then get into the development process with Docker Compose and the CLI. Stick a couple demos in there as well. So just a little bit about containers in one slide. For those of you that are new to Docker, containers have a number of benefits, and we'll touch on just a few of them here. The first is that containers give you a nice environmental consistency, so you get portability from those containers. So that image is consistent and immutable. No matter where you run it or where you started, it's exactly the same. And this makes the development lifecycle much simpler. So an image works the same on your desktop as it does in production, whether you start it today or scale your environment tomorrow. So there's no surprises. The environment or the application that you have inside your container is self-contained. So the image then becomes the version, and it makes deployments and scaling a lot easier because the image includes all the dependencies. And so much like you may have built images in the past for things that included the entire operating system image to start things like virtual machines, Docker images are similar, and yet they're much smaller and lighter. And so you're able to share them more easily and check them into an image repository much simpler than you could in the past. Containers are also flexible. You can create clean, reproducible, and modular environments. So whereas in the past you might have had multiple processes on the same operating system, like Ruby, your caching, your log pushing, now with microservices you can easily decompose your app into smaller chunks, and that reduces the complexity and lets each team move faster at their own pace, while still running the same processes on the same host if you need to, because there's no conflicts like library conflicts between those two containers. So this streamlines both the code deployment and the infrastructure management. But simply stating that Docker images start fast really sells the technology short, because speed's apparent in both the performance characteristics of starting the container and in the application lifecycle and deployment benefits. So yes, containers start quickly because the operating system's already running, but it's also much easier to set up those deployment pipelines with your development teams and let those teams work independently. So with that brief primer on Docker, let's talk a little bit about the EC2 container service and how it lets you run Docker containers on Amazon. So at the core of Amazon ECS, you have a cluster manager, which is a backend service that handles the tasks of cluster coordination and state management. And you may ask yourself, why do you need a cluster manager in the first place? Well, running Docker containers on your laptop is pretty simple. If you've downloaded Docker, you'll know that running Docker run for a single container is pretty straightforward. Running Docker run for a few containers that work together gets a little more complex, and that's where Compose steps in, and we'll talk a little bit more about that. But running multiple containers on multiple hosts quickly becomes a little more challenging, and so finding a way to do that, and also that monitors the state of your entire environment. So if hosts were to fail or containers were to fail, you are aware of it and schedulers can restart it. Becomes much more complex, especially as you keep adding nodes. And so having a reliable cluster manager is pretty critical. And on top of the cluster manager sit various schedulers. So cluster management and container scheduling are components that are decoupled from each other, which lets you build and use your own schedulers if you want, or use the built-in ECS schedulers, or use a combination of the two. And a scheduler works a lot like your Outlook calendar. So basically, when you want to start a container, it needs to find a place where it'll fit. And the placement requires things like how much memory or CPU you've requested for it, whether you've asked for certain ports. And so it finds a particular EC2 instance that meets the requirements that you specified for that container. And the ECS schedulers also include some additional logic. For example, many people that are running web applications want to make sure their containers are spread across availability zones so that if a particular availability zone were to experience problems, they'd have some redundancy. And so the ECS service scheduler also includes logic like that to make sure that your containers are evenly spread across AZs. So a cluster is just a pool of compute resources available to your applications. They're the EC2 instances you're used to using. You can start those up in an auto-scaling group, or you can start them individually. You can use spot instances, on-demand instances, or even your RIs. And ECS coordinates the cluster through a container agent that's running on each EC2 instance in your cluster. And the agent allows ECS to communicate with the EC2 instances in the cluster to start, stop, and monitor the containers as requested by you or by the schedulers you're using. The agent's written in Go and has a minimal footprint, and it's available on GitHub under an Apache license, and we certainly encourage contributions and feedback. So that agent is talking up to the ECS service, to the schedulers in the service, and the schedulers are running the containers in your cluster and then coordinating with other services and processes, for example, elastic load balancing in the case of long-running services. So that's really how ECS is put together. So the benefits that ECS provides you are that we make it a lot simpler to manage that large cluster, whether large as just a few EC2 instances and a few containers, or many hundreds or thousands of instances and containers. ECS handles the complexity of the cluster and container management, so you don't need to install and operate your own cluster management infrastructure. It's all available through a set of APIs that are scaled for you. So whether you're running in a single availability zone or multiple availability zones, or running lots and lots of instances and containers, it's the same APIs that you access, and ECS is taking care of all the scaling and operations behind the scenes. At Amazon, we've built a number of core distributed systems primitives that support our needs, and ECS is built on top of one of those primitives. And we then expose the state management behind those APIs to give you details about the instances in your cluster and all the containers running on those instances. And so the Amazon ECS APIs respond quickly whether you have a cluster with a single instance and a few containers, or a dynamic cluster that's scaling up and down with hundreds of instances and thousands of containers. And again, that accurate state information is super important, not only for monitoring the operations of your containers and your services, but also being able to make scheduling decisions. So knowing the exact state of that EC2 instance, whether it's available, how much memory it has left after you've scheduled containers on it, allows us to make accurate placement decisions with our scheduler. And just a quick view on the scalability piece, the graph here shows a load test where we added and removed instances from a cluster and measured the 50th and 99th percentile latencies on the described task API over a 72-hour period. And as you can see, the latency remains relatively jitter-free despite large fluctuations in the cluster size, all without you needing to operate or scale a cluster manager. And the set of API actions form the basis of solutions that you can build on top of ECS. A scheduler just provides the logic of how, when, and where to start and stop containers. And the ECS architecture is designed to share the state of the cluster and allow you to run as many varieties of schedulers as you need for your applications. In fact, we have a number of customers that are running custom schedulers, two of which spoke at reInvent, and the session presentations and videos are up online, and I'd encourage you to take a look at them if you're interested in more about using custom schedulers. So the optimistic concurrency control in place with ECS allows each scheduler to receive the resources requested without the possibility of resource conflicts. Customers that have already created solutions on top of ECS include folks like Meteor and Coursera that have created their own custom schedulers, as I mentioned with the reInvent presentations. So, as I mentioned, a scheduler understands the needs of a system, that is, the work that needs to be done, such as starting a container that needs 200 megabytes of RAM and port 80, and it looks to efficiently satisfy those requirements. And it then submits a request to the cluster state manager requesting the resource. And since ECS supports optimistic concurrency control, you can have multiple schedulers operating at the same time, so the cluster manager confirms that the resource is available and commits it to the scheduler. And the scheduler can then listen for events from the cluster manager and take action, such as maintaining the availability of your applications, and it can interact with other resources like load balancers. Amazon ECS has 2 schedulers to help find the optimal instance placement based on your resource needs, isolation policies, and availability requirements. It has a batch scheduler called run task, and it has a service scheduler with create service. Amazon ECS is also built to work with the AWS services that you value. You can set up each cluster in its own virtual private cloud. You can use security groups to control network access to your EC2 instances. You can store persistent information using EBS, and you can route traffic to containers using elastic load balancing. CloudTrail integration captures every API access to give you the ability to analyze those API accesses, resource change tracking, and compliance auditing. And finally, ECS is extensible. It can be easily integrated or extended through a simple set of APIs. ECS provides that complete visibility and control into your resources, so you can easily integrate and use your own container scheduler or connect ECS to your existing software delivery processes. For example, we have a number of partners, including folks like Shippable and Jenkins and Circle CI that have used these APIs to integrate into continuous delivery pipelines. So let's talk a little bit about web services. With the MVC design pattern, controller classes defined methods that map to URL patterns, and these controller methods model classes that encapsulate the business logic and the data of your core application entities. There's a number of problems, though, with kind of these monolithic MVC patterns. And the first is that as features and services are added to the application, the code base grows substantially more complex. Because all the application code runs in the same process in the server, it's difficult to scale individual portions of the application. If one service is memory intensive and another is CPU intensive, the server has to be provisioned with enough memory and CPU to handle the baseline load for each service. And finally, and more subtly, the engineering team structure often starts to mirror the application architecture over time. The microservices architecture is designed to address these issues. The services defined in the monolithic application architecture are decomposed into individual services and deployed separately from one another on separate hosts. And Docker containers really are natural for this pattern. Docker supports any application in any language. You define everything that's contained in the image using a Docker file, which is a complete manifest of the image. So now you always are able to check into source code all the changes you make to the image, and you're able to revert back if you need to. So the image then becomes a versioned artifact along with the Docker file that can be stored in a repository just like your source code. And you can store and ship these Docker images, you can test and deploy the same artifacts, and you can decompose these formerly monolithic services and microservices that let you decouple deployments and reduce conflicts. So even though the Docker containers might still be running on the same hosts, they're now isolated and you can scale them separately, you can evolve them separately. In fact, the teams could decide to use different programming languages for each of them if, for example, you might need to gain more efficiency through a different programming language. And so Docker each deployment is just a new set of containers, and this decreases the risk of change because rollback is simple. You can do things like red-green deployments and easily roll back by just pushing the old container image version. So let's kind of take a look at what a container build pipeline might look like. So by adding a build pipeline around containers, you can have your operations teams, for example, create certified base images with all the necessary patches and utilities. So maybe you start from a base Ubuntu 14.04 Docker images, You add in your utilities, maybe it's some log drivers or other sorts of patches that you need. And then you have a base image, and you can create utility containers like logging containers, Ruby container, MySQL container, that your developers can then start from. So instead of starting from Ubuntu 14.04, your developers will start from your Ruby Docker container image. And so the developers take those base images and then they add their code into it. So using the Docker file, they can then add code into the Docker image, along with other sorts of libraries and packages that are required for them to run their application. They can test that on their desktop, and then they can push that very same image to the production servers. So whether the developer is working on a Mac OS machine using VirtualBox, or working on a Red Hat Linux image or Ubuntu, they still have the same experience on their desktop as when they push to production. Now, of course, patches come down the line. Ubuntu might have some patches for their base OS. You then recreate your base images, and those base images then get updated with the images that your development teams are also pushing, and you can have those flow directly into your staging environments for testing. And so you no longer have to worry about how you get the patches pushed into production. The CI pipeline can basically push that through your every stage of your pipeline and perform the necessary tests in an automated fashion. So now that we have the Docker images, let's talk a little bit about how we define the actual things that we're going to be deploying. So instead of using a Docker run, as we mentioned, we're going to want to find an automated way through Amazon ECS to deploy containers. And whether you're deploying a single container or whether you're deploying a set of containers that work together, we define those in a similar way. I mentioned Docker Compose. There's a similar format in ECS that we call task definitions, because what you're going to be running on those EC2 instances is a task. And the task basically is the set of containers that need to work together. And that might just be your Ruby app, or in the demo we're going to give today, a quick PHP app. Or it might be a set of containers, like maybe it's an Nginx in front of a Flask, or maybe it's Nginx and Flask and maybe some sort of logging container that you have that logs to a custom log source that your organization uses. So when you think about a task definition, think of it as the set of containers that need to run together on the same instance, and the thing that you're going to be scaling in tandem. And so oftentimes people might start and think about maybe putting, for example, their web service and database together in a task definition. But those are really separate services when you think about it. If you have a Cassandra database, you're going to want to scale that at a different rate than you're going to want to scale your web tier. And so putting those into the same task definition essentially means that you're always going to be scheduling in a 1-to-1 ratio of web to Cassandra. So think about how your processes work together, and then logically deconstruct them into separate task definitions. And think about the tasks really is often being exposed through a single endpoint. So it's usually a web service or maybe a website, or even if you had a data tier, it's really one logical entity. So let's kind of go through a little walkthrough of a kind of a day in the life of, let's keep on the slides actually. A day in the life of how you would get started with ECS. So the beginning is you probably say you want to run a service. You're going to first get your EC2 instances provisioned into the ECS cluster. And so typically this is done with an auto-scaling group. Once you have the capacity that you can then run your Docker containers on, you want to define the task definition. So again, that task definition might be one or multiple containers that are scheduled together. So it might be a PHP app, for example. It might be a logging driver. You might also put inside that task definition other shared resources like a shared data volume. You declare with the ECS service scheduler the resource requirements for the service. So for example, for my web app, I might want to have 5 instances of that task running. So that's, think of that as the old equivalent of 5 EC2 instances. Here it's just 5 of those sets of Docker containers that you define in your task definition. And you can also register those behind a load balancer. And then the ECS service scheduler takes care of registering those tasks with the load balancer, making sure that they stay healthy. And if they become unhealthy, restarting the task on again, so that you always have the requisite number of tasks running that you've requested. So then when you describe the service, you can see the containers that are running on your EC2 instances, and you may decide to scale the service up and down. If you scale the service down, then ECS will remove those tasks from the load balancer, waiting for the connections to drain before stopping the tasks. You can also deploy new versions, and when ECS deploys new versions, it's a rolling deployment. So health checks are checked before the tasks are stopped, so we want to make sure that the new version you're rolling out is successful before we stop the old version. And of course, we'll go ahead and continue to drain those connections before stopping the old containers as well. So hopefully that gave you a thumbnail of how you might use ECS for running a service. Let me tell you a little bit about the ECS CLI. So ECS has a few different ways that you can control the tasks and Docker containers in your cluster. We have a management console that's a graphical management console that lets you view the tasks and instances that are running in your cluster. We also have there's the AWS CLI that lets you interact with every service through the services APIs. But one of the things we heard from customers was that there's many folks that really like CLIs, and they prefer to work with the CLI just like they're using Docker on their desktop today. But the AWS CLIs tend to operate at a very fine-grained level. It supports every single API in the AWS of all the AWS services, but you have to perform a number of those API actions in order to do various activities in ECS. And people asked us for a higher level CLI that simplified doing some of the common tasks that they had to do. We also heard from customers that they really liked being able to use Docker Compose on the desktop. They were already using it, and they wanted a way of taking those same Docker Compose files that they were using today and using those with ECS. So the ECS CLI answers both of those requests. We have binaries available for Mac OS X and Linux. It's open source. We appreciate feedback and pull requests and reporting issues as well if you have those. Through GitHub, and you can find download links inside our documentation. So let me take you through some of the ECS CLI commands, and then I'll give you a quick demo of how it can work with Compose. So one of the nice things about the ECS CLI is you can create an ECS cluster with just one command. And so an ECS cluster tends to be comprised of a number of things. Minimally, it's an auto-scaling group, but you probably also will want to create a specific launch configuration for your auto-scaling group that'll reference a particular AMI. You may want to create a new VPC for that, different security groups. So there's a number of different resources that have to get created when an ECS cluster is created. And we wanted to simplify that so you didn't have to worry about going and creating each of those resources individually. And so we introduced the ECS CLI up command that creates all those resources for you using a CloudFormation template. And so you pass in things like your EC2 key pair name, the size that you want for the cluster, what instance types you want to use, and then the ECS CLI will take care of creating the cluster for you. Now once you have your cluster up and running, as I mentioned, you want to create the task definition. In this case, we're going to use Docker Compose to do that. And so Docker Compose is an open source tool that is available from Docker. You can download it and use it on your desktop. And it lets you easily model and run multi-container services. And so you can run those services on your desktop. You can run them on AWS. You can store the Docker Compose file in source control. And for the purposes of this demo, I'm going to have just a simple one image web application, but you could easily extend this to be multiple images. For example, if I were to put an Nginx verse proxy in front of my web application here. Docker Compose is rich. It lets you do things like defining ports and defining volumes, setting the memory you want, the CPU you want. And so the nice thing about this is you don't have to run the Docker run every time that you want to bring containers up. You can just use Docker Compose to bring up those containers. And the efficiency of this becomes pretty apparent, especially as you're evolving and making your web application more complex. So to run locally, I just use Docker Compose up, and Docker Compose then creates the Docker containers that I referenced inside my Docker Compose YAML file. And so it's really a declarative way of getting a set of containers up and running. Oops. And then, of course, once I'm happy with how things are working in my local desktop environment, I'm probably ready to get that running on ECS. And so there's two different ways you can bring up your Compose file in ECS. And it relates to the two different schedulers that we have in the system. You can use just ECS CLI up, which just runs the Compose file as an individual task. And that's good if you want to just run that task and you're not worried about maintaining uptime. We also have the command ECS CLI compose service up, which uses the ECS service scheduler to maintain a number of tasks, and if those tasks stop going, then it'll restart the task for you, which is appropriate for things like long-running applications, web services, and the like. And so for the purposes of this demo, we'll be using the service up. And you can specify a scale factor, so you can scale this up and down and deploy new versions. So we can then view the containers that we've created, and we'll go ahead and in the demo scale the service up, and we may even change the service to use something different, like maybe add another container to our Compose YAML, and then update the service. So let's go ahead and we'll go to the demo now. So I'll go ahead and now bring up my terminal. And I'm going to go ahead and show you my Docker Compose file, which is, as I mentioned, very basic. Just have an image and some ports referenced. So basically, this is an image that's available for me. I have basically the container port I'm mapping to my host port. And Docker Compose has a nice rich syntax, and so this can be a lot more complex if you want it to be, but we're just going to keep it simple for this demo. And as I mentioned, if we look at Docker PS, there's nothing running here on my desktop. I could, of course, do Docker run and start up that same image, but I want to make sure that my teammates and I are all running things in exactly the same way, and so to avoid fat fingering and typing in the wrong parameter so that things might work on my desktop and might not work on others, I'm going to go ahead and just use this Docker Compose YAML, which I'm going to check into my source repo. So now let's go ahead and bring up those containers. So let's Docker Compose up. And Docker Compose up just uses the Docker Compose YAML by default. You can use different file names as well, but just kind of sticking with the basics here. And to show you what this is doing, I'm going to go ahead and just put my IP address in here, and you can see the container I just brought up. So fantastic, just a very simple PHP app here, but it gives you a sense as to what this is doing. So just exiting out there. So let's take a look at the ECS CLI, and let's take a look instead of PS. I'm not going to go through the ECS CLI up because that takes a little while. So in typical cooking show format, we're going to use an existing cluster that I've already created. But we can see that with the ECS CLI PS that I don't have any containers running. So let's go ahead and I'm going to basically take that same Docker Compose YAML, and I'm going to go ahead and run it with the ECS CLI on my cluster. And we can see that basically it's using a task definition that's been created for me. So the task definition is the ECS equivalent to Docker Compose. it's basically changing the service to just use desired count of 1 because I didn't specify any scale, so it's just assuming that I want 1 instance of that task running. And right now it's waiting for that task to get started. So we can see the desired count's 1, the running count's 0, and now the running count is 1. So if I were to go back and do the PS, we can see indeed that that I have that task running, and so we should be able to go to this IP address and also see my my application running, and indeed it is. So success. But you know, of course, you're probably you know, going to be dealing with you know, wanting to scale your service up, and so if I wanted to kind of change the desired count, I can also do that through the ECS CLI. So let's here on the service command, I'm going to go ahead and say scale 2, and so now my desired count you can see is 2 instead of just 1, and so it's going to go ahead and wait until I have both tasks running. And then I'll be able to take a look and do another PS and see the tasks that I have running in my service. So what's nice is, you know, everything here is running through my command line. It's all part of my development process. So as I'm evolving my Docker file, I can quickly also evolve my Docker Compose YAML. I can test that here locally on my desktop, and then push those changes out to you know, my source repos, but also to ECS. So I might have my staging environment on ECS. So let's go ahead and take a look at PS. And so we can see indeed that we have a second task that's running in the cluster. And so this really kind of simplifies that whole development process. I can also scale my cluster up and down. So if I wanted another EC2 instance running in my cluster, I could just scale that. Right now I have 4 instances. I could say that I want 6. Have to, of course, add the right flags. And shows me to go off my demo script. You should be able to scale your cluster as well. We'll defer this for a minute. So you can scale both clusters as well as services through the CLI. And if we were to go to the console, we can take a look at the services that I have running. So here's my webinar service. We can see that that there are the 2 tasks that I've requested to run. If I wanted to, you know, of course, sometimes things happen to tasks. Like here, I'll just simulate this task failing by manually stopping it. And so now I have less than the desired count of tasks running in my service. If I kind of go back to my service, I can see that you know, I have a oh, it spun up another one quickly. Basically, we can see that if I kill off one of the tasks, the service scheduler will notice that task is killed off, and it'll spin up another instance of the task so that I always have the desired running count of those tasks. So hopefully I give you a sense as to how the ECS CLI works. Let's go ahead and we'll go back to the presentation. And I'll mention a couple of the things, the considerations when you're using the ECS CLI. So there's a few things to think about as you're using the ECS CLI. The first is that this is version 0.1 of our CLI, and we're working on a few items. So one of the items that we're working on is support for all the Compose attributes. So today, for example, the ECS CLI does not support Compose's build attribute. The documentation gives you a list of the attributes that are supported in the Compose, and so please do take a look at the docs, and we're looking at how we can, we'll be enhancing the ECS CLI over time. You can take a look at that inside the GitHub repository. The second thing is that today with ECS services through the CLI, there's no way to create a service with an ELB. So today you can create a service using the ECS CLI compose service up, but it just creates a regular service without the ELB. So that's something else to keep in mind today. That is on the enhancement list as well. And the third consideration is just service discovery. And so if you remember back to when I was talking a little bit about decomposing your services into discrete task definitions, which ended up being discrete compose files, that really means that your web application, which may be talking to a back-end application, is going to need some way of finding that back-end application. And because you don't probably want to use Docker links for that, because those services may be scheduled on different hosts, you'll want to find a different way of performing service discovery. And there's a number of ways that have been described for doing service discovery. I'll just mention a couple of them here. Docker talks a little bit about the ambassador pattern, which basically runs a container, a sidecar container that acts like a load balancer. DNS is another mechanism, and elastic load balancing is yet another. And so you could use elastic load balancing for service discovery between multiple ECS services, and you could pass in the DNS name for your load balancer through environment variables. And so that's kind of a pattern that we see working pretty well for service discovery within ECS. The last option, of course, is to use service discovery services like Console, and we have a blog on how you can use Console with ECS. So with the load balancer pattern, you can, in your local dev environment, have an environment variable that points to a local copy of the service if you're running it locally, or a mock service that you might have available to you in a staging environment, and then you can just change that environment variable when you push to your containers to production. So with that, let me turn it over to Q&A. I appreciate the interest in learning about the CLI, and happy to answer any questions that you might have. So a question on when will ECS support the Docker overlay network introduced in 1.9? We're working on 1.9 support right now. We plan to launch 1.9 and the ECS optimized DOMI this month. And the Docker overlay network will come a little bit later from that. So certainly something we have our eye on, and we do want to provide support for the overlay network in ECS. Question on assigning elastic IPs to containers. Today, elastic IPs you can assign those or associate those with your EC2 instance, and then you would need to basically plumb those up to the container. We don't have a mechanism today to assign elastic IPs directly to containers. That's a great piece of feedback for us for the roadmap. Question on Elastic Beanstalk with containers per instance. So today, Elastic Beanstalk is actually a really nice environment for running containers. The multi-container Beanstalk runs on top of ECS, and if you have a web app pattern and you like the Beanstalk's automation, then that might be a really good option for you. Today, it deploys a single task per EC2 instance, which can work well for tasks that are sized for your EC2 instance. If you do want to run multiple tasks per instance, then you would want to use ECS today. A question on persistent shared storage for containers. We have a blog we published recently on using EFS for persistent shared storage for containers. We don't have a built-in mechanism for data persistence using EBS. We do support EBS for data persistence for the lifetime of the container. But if you're trying to run, for example, a database where you want to have the same EBS volume no matter where the container is scheduled, then the EBS integration we have today would not meet those needs. The EFS blog, though, talks about how you can use EFS, Amazon's Elastic File System, for that purpose. So I encourage you to take a look at that blog. Question on, is the ECS CLI a subset of Bodo? So Bodo is like the Amazon CLI in that it provides the very basic API parity with our APIs. And so Bodo and the AWS CLI, for example, instead of doing ECS CLI PS, I would instead do AWS ECS describe tasks, and it would provide a very different formatted task result. If I wanted to scale my service, I would need to find the service name, and then I would call update service on that. So it's a lower level than the ECS CLI. The ECS CLI is meant to be a higher level CLI that lets you in one command do what might take you multiple commands with the AWS CLI. Question on, is it possible to have the ECS CLI integrated with the AWS CLI? Love to learn more about your use case there and why you'd like it to be integrated with the AWS CLI. We're definitely eager to hear more about what sorts of features customers want on the roadmap, and you can either talk about that here in the webinar or feel free to open an issue on GitHub. Question on getting the slide deck. Slides and the recording will be sent over email subsequently. Question on Windows support of the ECS CLI. That's a great question. I'm glad to hear that there are Windows users out there. I'm one of them. Yes, would like to have Windows binary for the ECS CLI as well. I don't have a date for you, but that's a great piece of feedback. Thank you for letting us know that you want that. So a question on my demo failure on scaling the instances in a cluster. That does, so I showed you in the demo scaling the tasks in a cluster, and that's depends on the container specifications in my Docker Compose YAML. You can also scale the instances in your cluster, and that's using the auto-scaling group. So the ECS CLI up basically creates an auto-scaling group with a launch configuration that's you specify with the ECS CLI up option. So you can specify, for example, the instance size, the instance type, all that sort of stuff. And then the auto-scaling group launch configuration has that. And then when you say ECS CLI scale, it'll just change the auto-scaling group desired count. So the question is, does Docker linking work across AZs? So Docker links only work on the same host. So this is an important point kind of to the service discovery that I mentioned. So you have to have your containers on the same host for a traditional Docker link to work. If you want to link containers across hosts, that's really more of a service discovery sort of mechanism. And so you have the mechanisms I mentioned for service discovery, things like dedicated service discovery services like Console, load balancers, DNS. ECS provides load balancers for services, and so if you have a front-end web service that needs to talk to a back-end service, then you can reference the load balancer. And the nice thing about the load balancer is it's dynamic, so as you're scaling your service up and down, then you still have that one endpoint that always gives you a healthy endpoint to resolve the request. So the load balancer is doing good stuff like round robining. If tasks fail, then it doesn't submit requests to those tasks anymore. We're monitoring the health check, so we'll start up new tasks. So that's kind of how service discovery can work in an ECS environment. But you're, of course, free to use other services like Console, and we have some blogs on how you can do that as well. And so a follow-on question was, can you link containers across task definitions? And the way to link containers across task definitions is to reference those the load balancer endpoints. And so one mechanism, I should say, you can certainly use things like console or DNS as well. And so the mechanism you use to link your services it really kind of depends on what you and your team are most comfortable with. If you prefer using things like DNS, that DNS SRV records are a good option, and that's what services like Console use. If you like environment variables and load balancer endpoints, that's certainly another option. And then, of course, some folks like ambassadors and sidecar patterns. One challenge sometimes with the ambassador pattern, though, is that if you have services that are scaling up and down a lot, you need to keep those ambassadors up to date, and so that can be a bit of a challenge. The nice thing about using elastic load balancing is that you don't have to worry about actually managing the load balancer. That's managed for you, and it's all built in with health checks and integrated with the ECS service scheduler. A question on using the ECS task in CloudFormation. You can use CloudFormation with ECS today. The question is, why can't you create an ECS task by itself in CloudFormation? Only services are possible. That's a good question. CloudFormation is really meant for creating resources, and we should look at how we could enable you to create individual tasks in CloudFormation. I think that the original thinking was that because a CloudFormation template attempts to create an environment that persists, and tasks created by themselves don't really persist, and so there would be drift from that CloudFormation template potentially immediately after creating it, that might not be as valuable, but it's good to hear feedback that that there are use cases. I'm not quite sure what the use case is, and would love to hear more about it, maybe in the forums or elsewhere, but good to hear about additional requests you have for CloudFormation integration. A question on configuring ECS to run one Docker container per each ECS cluster instance. And so I assume the request here is things like logging agents and things like that you want to run just one per host. We have a section in the documentation that describes how you can set that up. So please take a look at the docs, and you'll find a description of how to get that set up. So probably time for another question or two, if folks have them. Looks like not. Thank you very, very much for taking the time to join us today. Very much appreciate it, and please do continue to give us feedback on the ECS CLI. We do appreciate issues and pull requests. Thank you much.